Assalamualaikum warahmatullahi wabarakatuh. My name is Amir Ashraf bin Abdul Ghani. Now I will discuss about on how I did the part A for this lab session. So the firstly we want to define the system parameter in this MATLAB. So the given system parameter is this one. So if you run this, we will get this: m1 equal to 1, k1 equal to 1, f1 equal to 2, m2 equal to 1, and then so on. So after that we want to define the equation in matrices for this MATLAB. So we state the equation that we get into this MATLAB. So we name these matrices as A. So the first, so if we run this, we will get this: s square plus 3s plus 2, then negative s, negative 1, then negative s, negative 1, then s square plus 2s plus 1. Then we want to find the s1 over f. So s1 over f, so we replace the first column with 0f with the original one. So this part is changed with this part. So after we run this, we will get this one. So 0f, negative 1, s square plus 2s plus 1, and then also with the a2, the same one. Just the a2, we will replace the original matrices for the second column with the 0f. So and then we want to find the s1 over f, so determinant. So we want to find the determinant. So for s1, the determinant a1 over determinant a. So if we run this equation, we will get this s1. So f times s plus 1 over s4 plus 5s cubed plus as square plus 5s plus 1. So for the x2, we'll get f times s square plus 3s plus 2 over s4 plus 5s cubed plus 8s square plus 5s plus 1. So this is for the x2. So then we want to plot in the graph, so we use this coding. And then we will get this coding. I'm sorry, that is for figure 2. This one first. So this is the graph for the s1. And then for the x2, we run this coding to get the graph, the step response. So we get this. So lastly, if you want to combine both s1 f graph and s2 over f graph, so we use this coding. So as you can see, there are two step response in one graph. So we want to determine that. So we can use we input the legend. So we see now, for instance, now the blue line is the s1 over f. So and the red line is the s2 over f for this step response. So I think that's all from me. Thank you.
Now I will explain on how to obtain transfer function for electric network using MATLAB. First and foremost, declare the variables such as R1, C1, R2, and etc. And write the equation, the form of matrix form. This equation can be obtained by using the mesh analysis. In this case, there are only two loops. So there will be two equations will be right for this circuit. first equation will focus on I1 loop and the second equation will focus on I2 loop. So this is the first equation, which is I1 loop, and then the second equation is mainly focused on I2 loop. So in order to find the VL, we have to calculate the value of I2. Therefore, we have to replace the I2 value with the Vn0. Then the determinant of A2 will be divided by the determinant of A to obtain the value of I2. Since we already have I2, we just have to find the VL, which will be simply multiplied by S, which is the inductor impedance. Then to create a transfer function, we need to declare the numerator and denominator that obtained from the VL and use the TF function to generate the step response. Once everything is done, run the code. After we run the code, we can see that the variables are declared and the matrix form of A, A2, and then the answer of I2 and VL, then the transfer function of VL, and then this is the step response of this circuit.
Hi Dr. Sadikin, I am Shashi. Today I would like to explain about the Simulink model for the Part A mechanical system and also Part B electrical network. Firstly, I would like to explain about the Simulink model for mechanical system. This Simulink model consists of 3 blocks. First one is the unit block, second one transfer function block, and third one is the scope block. This unit step block is to generate the unit step response. Second one is the transfer function block to apply all the transfer function numerators and also denominators into this to get the correct response, and finally the scope to see the graph response. This transfer function is for the x1 over f, which was obtained from the command window just now from the MATLAB coding. As you can see here, we can edit the transfer function numerator and denominator coefficients. Numerator is 1 1, which represented the s to the power of 1 and s to the power of 0. The denominator is 15851, which represents from s to the power of 4 until s to the power of 0. Once everything is set, we can simulate the model now. As we can see here, this is the unit step response for x1 over f. Now let's look at the Simulink model for x2 over f. x2 over f consists of the same blocks, which is the unit block, transfer function block, and also the scope block, except for the transfer function numerator coefficients. We obtained the coefficients from the MATLAB command just now from the coding, and the coefficients are 1, 3, and 2. So 1 represents the s to the power of 2, 3 represents s to the power of 1, and 2 represents s to the power of 1. As I did previously, everything is set. Now we can simulate the model. And this is the unit step response we obtained for x2 over f. Now let me explain about the Simulink model for electrical system. This Simulink model consists of 3 blocks. First one is the unit block, second one is the transfer function block, and lastly the scope block. This unit step block is to generate the unit step response. Second, the transfer function block is to determine the transfer function, and lastly the scope block to see the graph of the unit step response. So firstly, this transfer function was obtained from the command window, as we saw from the MATLAB coding just now, which was explained by Arvind. And this transfer function block actually can be edited. All the parameters can be edited. As you can see here, numerator coefficients was 1100. This is because the s cube and s square has 1 1 value, and s to the power of 1 and s to the power of 0 is not there, so it becomes 0 0. Same for the denominator coefficients, 2541. So the 2 is for s to the power of 3, and 5 is s to the power of 2, and 4 is s to the power of 1, and finally 1 is s to the power of 0, which is also known as 1. After everything is set, we can simulate the model now. We can see here, this is the unit step response that has been obtained for the transfer function of the electrical system. That's all from me. Thank you.